everyone. I am Ving. I am representing Automatic, one of the members, one of the earliest members of the AI Alliance. And I am part of the tools and applications work group of the AI Alliance, right from the early days. And today, what I would like to talk to you about is a key initiative, a key product coming out of that tools and applications work group of the Alliance. This is called the Dana Agent Native Programming Language. By the way, I have put in the chat a link to a form for you to just spend a couple of minutes giving us your names and a GitHub ID so that you could be invited into the early access private beta program of Dana. Dana is currently in early access review, right, and collaboration amongst various members of the AI Alliance. So if you are interested in not only using tool, but also seeing the code being developed, then definitely give us your names and GitHub IDs for invitation. So can I have so this session is meant to be very interactive. It is not meant to be a heavy, laborious sessions on various things, agentic. I want to have a very light time with you, getting to know you as AI developers, hearing from you about various things you would like to have better done in the AI development work. So definitely, I look forward to having a lot of reactions or comments during the session. Please feel free to put your comments or questions in the chat, or raise your hands. We'll monitor the reactions on the call, and we'll have some interactive Q&A during the session. Right? Can I have a quick survey among people on the call here? How many are day-to-day AI developers, especially agentic AI developers building AI agents? Right, so I start to see quite a lot of reactions, hands up in the and comments in the chat. Right, so quite a lot of us. Now, the generative AI is very exciting. I mean, the models are getting better and better. Capabilities are improving very fast. And there's a lot of exciting intelligence coming out of the foundation models. But at the layer of developing agents based on the foundation models, and make these agents work in various industries, the life of the AI engineer is actually not that great, right? I want to hear a lot from you as well, but what is on the screen is basically my life as an AI engineer, not too long ago, right? Basically, there's a lot of prompt chaining, a lot of API to put together, just a lot of glue logic between prompts that need to be done carefully because they are very brittle, right? So how we call it is we call it a Frankenstack. It's actually a very messy apparatus that has to be put up in order to cope with the probabilistic nature of the LLMs, right? And then building agents out of raw LLMs is not a very smooth and enjoyable experience, in fact. So I have this set of frustrations recorded from various AI engineers across the AI Alliance about the process of building AI agents, right? So prompt after prompt, um, each prompt trying to fix the inaccurate things of the previous one. There's a lot of laborious coding. There's graph edges and nodes being needing to be maintained, right? Having little to do with my actual business logic. Right? So basically, so when we got together in the tools and applications work group, the AI Alliance, one of the key questions is how can we make this experience much better, right? What tools can we bring to members of the AI Alliance and the wider community? Uh, what tools can the AI Alliance champion in order to greatly improve the day-to-day development experience of engineers like us? And the answer is that we actually decided to innovate on a brand new programming language with a smart AI powered runtime, right? And with a lot of first class properties and affordances for the agentic AI era, right? So in very soon in the interactive session, I would like to show you some key building blocks of this programming language that are optimized for agentic AI development. Things like concurrency, things like workflow, function composition, things like agents that can take on different sets of expertise for problem solving. Right? So these are um, considerations and concerns that um, are addressed imperfectly in current tools, and I want to show you and then have you get a feel, right, of how different it is to do development in a new environment, and instead of the existing tools like LangChain or Llama Index. So, what? Oh, I see I see some comments on the chat here about the Frankenstack, AI and NLP. Um, yeah, I can relate a lot with your comments, and we should definitely chat more of these during the Q&A. So let me jump right into the interactive environment and show you what the new lifestyle of a agentic AI developer can be like. Let me know if you see my interactive environment coming up.
Yep, we can see it.
I see. Okay, so this is the like a repo of the Dana programming language. And by the way, for those who are new to the AI Alliance, Dana stands for Domain Aware Neurosymbolic Agent. So the history of these is from a paper that we published last year from a collaboration among various members of the AI Alliance on zero techniques that eventually evolved into this programming language. I can talk more about the academic foundation of Dana a bit later in the Q&A, but now let's delve right in. So the first thing I would like to highlight as a need that are felt very acutely by many AI developers is concurrency. So, who among the engineers here are very very frequently deal with async and await statements in Python, and then who basically program a lot of concurrency in their programs? Okay, Page Horton all the time. Andres, okay. Okay, concurrency is a huge pain. Uh, Nakamura, Ryuna. All right. Um, so I um I cannot remember for the life of me. I cannot remember completely how to write async await um, in for a complex program that is bug free. Is really really hard, right? And uh, that is something that I wish I never have to deal with, and now I no longer have to, right? So Dana as a language is concurrent by default. Right? All the commands, all the function calls in Dana are concurrently executed by default. So let me start with something like I'm gonna call an LLM. Say, tell me a long, beautiful story that is inspiring and about futuristic innovation and have the main characters overcoming huge challenges. Okay, so basically I'm requesting a big story. So see how my cursor is returned immediately, right? So I actually didn't have to wait for the LLM call to finish. I could actually start doing other things while the call is being performed, right? Is being fulfilled by the LLM backend. I can in fact send in multiple prompts at the same time, right? I can, if I'm greedy, I can send in a prompt on math, in a prompt on AI. I can define a function while those things are going on. Right? And I can start doing things while the execution takes place. And this is a huge efficiency gain in the age of uh, generative AI, right? If you really profile the time taken in terms of the execution of a typical generative AI program and agent, 95%, maybe even 99% of time is taken by the LM calls. So all the senior AI engineers are very busy trying to parallelize this, make as much as possible, right? Making concurrent calls, right, in your programs. So in Dana, everything is taken care of automatically. You could see that the commands I sent in just now, including the functions, actually very simply coded. My function is a simple function with a return statement. There is no async, there's no await there. The runtime of Dana just automatically takes care of executing these function calls concurrently, so that the throughput is improved like amazingly. I think the throughput can easily increase 5 times, 10 times, 15 times, thanks to the automatic concurrency. And I start to see some questions about how to do integrate LLM with Dana. In fact, Dana has a LLM powered runtime. So a lot of the um, handling of the program interpretation, program execution, um, problem solving, workflows are handled by an underlying LLM at the back end of Dana. So I can talk more about that aspect of the infrastructure later on. Right? So there is basically a resource, a system resource inside every Dana session that is an LLM. Now, another aspect um, of Dana, which is an agent native programming language, is first class agents. Right? Declaring agent in Dana is very, very simple. Let me introduce you to one such agent. Let's let's have agent Dave. Okay, so I just basically use a keyword called agent, and I set a name Dave, and immediately in my Dana program, Dave is an agentic entity, right? Dave as an agent ships with various capabilities such as built-in memory and communication interfaces that make it very easy to work with. So I can start chatting with Dave immediately, right? I can start interacting with this agent Dave. Um, okay, so I'll say, hey, hi Dave, thanks for hosting me at AI Alliance uh, event in Tokyo in June. Okay, so I can start interacting with this agent, right? So I can add in another agent, right? Agent Ving, myself. I can start having these agents interacting with each other as well. I say, hey, I can say Dave. Okay, I can put Ving into the interactions with Dave. Okay, he's a quiet guy, but if you just say, you know, neuro symbolic, okay, something like that, something about Ving. Okay. Oh, so Dave, okay, yep. So yeah, I actually know Ving. Okay, so basically, agents are first class entities in Dana. The moment you declare something as an agent, they can already start. They can already interact with you. Can already interact with other entities in the program. Many of which can be other agents, and then they can also start solving some problems together, right? So I want to introduce to you agents that can have very sophisticated skills. Okay, so let me bring in an agent that can be made quite advanced. By the way, I see various comments and questions here. Thank you for these. I'm mentally registering all these questions, and let me address them a little bit later, maybe in 10-15 minutes, when we have some examples that are related to what you are asking right here. So thank you for and then keep the questions coming on in the chat. Okay, so I'm not going to declare an agent. Okay, agent 007, for example. Okay, and I'm gonna make this guy smart. Okay, so let me see. Okay, let me see. Like, what do you even know? Okay, let me see. Okay, I have access to vast information, many topics, science, technology. Wow, very modest guy, 007. So I'm gonna ask it a so since 007 is so confident, I'm gonna start asking something more technical. You know, do you know the tech company AMD? Okay, so 007 knows AMD. So I'm gonna start getting into a domain that is very specific, and we're gonna test this guy's skill. Right, I'm gonna go into the domain of financial analysis. And by the way, I do have a code package and so several sets of content related to financial analysis here in order to test these agents. Okay, I'm gonna let's test this guy on the annual report of AMD. Okay, I'm gonna say 007 is AMD capital intensive. Okay, and I'm gonna say, hey, I'm gonna give you these resources, which is the AMD annual report. Oops, it must be 007.solve. This is a problem solving ask. Okay, so 007 says AMD is capital intensive. It's in semiconductor, has lots of R&D design infrastructure. So very have a lot of capital cost. Can I ask for your comments on the quality of this answer? What do you think about the current answer from 007 about AMD capital intensity? Are you happy with it? You can put in the chat. Okay, so Andres is too long, complicated. Keshav has a, can we have more numbers? So Keshav is not happy that this guy makes a generic statement about AMD. All right, so I think there is a sense that this answer is generic, is sounds plausible, but doesn't have a lot of supporting details, right? It's certainly not an expert answer. So, I'm gonna see. Okay, I'm gonna check on your real expertise. What expertise do you actually have? Right? What domain specific expertise it has? So when I inspect, it actually has it doesn't really have any special expertise. So that's why it is answering in a generic way. But now I'm going to make it an expert. I'm going to make a 007 an expert in financial analysis. I'm going to give it domain expertise in financial analysis. So 007 expertise, I'm giving you financial analysis expertise. So you now have it. Now do again, try again. Okay. So now I think the guy is thinking harder, right? It's gonna take a while, because he's now with this expertise, he's gonna think more carefully. Meanwhile, because this the concurrency in Dana, I don't have to wait for 007 to finish. I'm gonna do something else. Okay, I'm gonna study some math while waiting for 007. This is the very point of concurrency. Okay, so 23 problems by Hilbert, stated in 1900. Which problems have been solved? Okay, so a couple have been resolved. Okay, and then I can also start chat. So now 007 has returned me an answer. So it has done some analysis much more carefully, and it has provided me some metrics on AMD, right? Total fixed asset, total assets 5%, return on asset is 7%, capital expenditure is a small percentage of revenue. So on balance, AMD is actually not a very capital intensive company, mainly because the fixed assets ratio and the capex ratios are low, right? So this directly addresses several comments that you have earlier in the chat. Like where are the numbers when you make a claim about a company being capital intensive or not? How can you, on what basis are you making your claims? Right. So agents in the data world can be armed with domain expertise, and they can utilize that expertise, and they can inspect the relevant bits and pieces in that expertise in order to solve problems with much greater depth and precision, and 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 a lot more consistently and consistency and accuracy in terms of their output as well. Right? And the ease by which you can inject domain expertise into AI agents is just as easy as just an assignment like what I performed earlier, right? You directly give an agent a list of expertise modules, and later on I will also give you a glimpse of how these expertise modules can be constructed in Dana, and why a neurosymbolic language like Dana is actually a perfect form to encode a lot of specific domain expert knowledge, right? So Keshav immediately raised a question: can we get a list of expertise libraries that can import it? Very good question. Yes, indeed, we will construct and distribute quite a few standard expertise libraries in the data ecosystems in the coming period. This is the whole point, right? The agents that are smart need to have access to domain expertise in forms that are conducive for problem solving. So these are some of the key highlights about what is different about developing agents in data. First of all, you can feel that while things are being processed, the fact that the runtime is concurrent allows me to continue doing many things, right? Or I can easily get 5, 6 parallel jobs run while a complex problem is being solved, right? So there is a lot of inbuilt parallelism in the way things are executed, and yet the code that the AI engineer like you and me have to write is very, very simple. There's no complex async await. There's no bookkeeping to do in terms of when to exactly make a async declaration and when to make an await statement, right? All of that mental load is taken away. So just so that we can focus on the true logic of the programs and the agents. And by the way, another thing very cool I want to show is that these agents that we call by names here actually have inbuilt memory. So let's say I'm happy with my day's work. I went away. Tomorrow I come back into another data session or program. Okay, and I see Dave again, Agent Dave, and say, right? So Agent Dave actually remembers that we met in Tokyo in June. So agents are first-class constructs that have identities and built-in memory, and this is tremendously useful when you construct and orchestrate multiple agents working together, right? Otherwise, how the amount of logistics you have to perform for it to remember the history of what it has been exposed to, what knowledge it has acquired. It's just a lot of things to do for a developer. I can also chat with Dave. Do you keep track of stuff happening in neurosymbolic AI? I need some advice, some technical advice. Okay. Okay. See what Dave says. Okay. Say, hey, I do keep track. Uh, anyone you know is deep into this? Hey, Dave recommends that. Hey, if you want to chat about neurosymbolic AI, I think is a guy to who is who can talk like forever about it, right? So this built-in memory, um, coupled with the ability to solve problems, are very key to complex problem solving, especially when multiple agents need to work together, right? So in the time slot today, we don't quite have time for me to show such complex scenarios. But what I want to spend some time giving you a glimpse of in the time remaining is the form of domain expertise that can make data agents very smart and capable. I want you to show um, such intelligence in certain um, canonical forms. So let me expand to you on the left-hand side here, the content of the financial analysis domain expertise package that I provided to Agent 007 early in the session. So it is actually a full code package. It is like a Python package, a Java package. This is code, right? But it is code that contains intelligence in very powerful forms, right? And one of the main forms to express intelligence in data is what we call workflows. So workflows functions that can be composed together in order to perform some very precise task. So let me open this submodule called liquidity, right? .NA here. It is a data module that has various workflows having to do with evaluating the liquidity metrics of a company. So, for example, in order to calculate the quick ratio, okay, quick ratio is a key measure of liquidity. Um, you would piece together several functions like this. First, you get the quick asset um, of the company. Quick assets is basically a sum of your cash, your short-term investments, and your basically things that you can turn into cash quickly. And then you also get to extract the current liabilities of the company, and then you basically divide the two together. So note that this workflow has a particular flavor in terms of syntax. It has a square bracket syntax and a pipe syntax. So things in square brackets are done in parallel. They are independent. They are not sequentially dependent on each other. Whereas the pipe indicates that this step needs to wait for previous steps to complete and intermediate results being available for combination. So this is a very succinct way, not only both a succinct way to write a piece of key intelligence, and also an indicator to the data runtime to how to efficiently execute this, right? Because things that are done in parallel will automatically be executed concurrently by Dana. And complex evaluations such as capital intensity, even more beautifully expressed like this, and you really see the full power of concurrency, right? In this evaluation of capital intensity, you basically can have a workflow where four key metrics are calculated in parallel, and then feeding into a final expert assessment, right? And and I want to show you the top level of this package. This intelligence, this domain expertise package brings to the agents, such as the 007 agent earlier, easily 50, 60 workflows. Right? Basically arms the agent with all these expert, precise sequences of operations to solve things very precisely. And the solve method in the agents is very smart in terms of deciding which of these workflows can be one, can be two, can be three to run in order to satisfy and to find a solution to a stated problem. Right. So and at this point, I think let me pause a little bit and start addressing several questions that I see on the chat. There have been many comments on the chat over the past 10 minutes or so. So let me start answering Keshav's questions on a list of libraries and expertise from which intelligence or domain expertise can be imported. Absolutely, we are building a library module called Nodes within the data distribution. Nodes stands for knowledge organization and workflow structures. Right? So there would be likely a data.nodes library that ships with the data distribution, and from which things like financial analysis, things like standard widely accepted wisdom in various fields are packaged. And if somebody is interested in such domain knowledge packages, they can easily import and start using them right away. Right? So right off the bat, people can have pretty smart agents in those fields. Let me think. Kevin asked a question about the models across manufacturers, and prompts are challenging to master. How do you troubleshoot these the complexities with the models? Kevin, let me know if I understand correctly. I interpret your question as having to do with the language models underlying the operations in data. Right. And then you are right that there are right now a very there's this great diversity in the LLMs available, and a lot of prompts. When you do prompt training, a lot of prompts are very LLM specific, and so specific that if you switch providers, the outputs can change a lot. Right? So in data, we treat LLMs as just a standard resource, and actually a lot of the time, the you can get most of these things done on a local LLM. In a coming distribution of data, everything would be working right away with a local, pretty compact LLM that you can have on your laptop, and all of these intelligence and problem solving would work just fine. Right? That is the point of having a language like Dana that combines LLM and the symbolic program structure, because the symbolic program structure gives you that control, gives you that determinism in output, whereas the LLM gives you the flexibility and the fault tolerance. So um, given just the right combination built into the runtime, you can get a lot of precise and smart things done with just about any LLM, including things that run on your laptop. Um, Let me pick a question from Nakamura. You want to try this out and try Dana out on your environment. So we invite you to register for the early access program. Uh, the form for which I sent earlier in the chat, and I will also put in again here. So we are inviting developers who provide GitHub IDs with access into the live code repo of Dana, so that you can see the ongoing development. We are also making PyPy releases, starting with a major release coming next week. And so a lot of these can be very easily installed and then tried out on your laptops very soon. So I do invite you to follow both the private beta program as well as the public releases of Dana in the coming weeks. Next question: how does Dana communicate with the outside world? So Dana has first-class support for resources. Resources can be documents, can be MCPs, can be other agents that you bring in through A2A. So it is able to communicate with external resources that way, through basically through all the standard means of agentic communication. And Dana is also very nicely interoperable with Python, uh, so that Dana will can call your existing Python programs and modules, and Python applications can also import and call Dana very easily. So that is yet another integration patterns that allows Dana to work with external data sources or applications. Um, Another question is what is the difference between module and workflows? Um, Modules in Dana are just similar to modules in Python, and in fact, Dana syntax is very similar to Python. It is in order to make it very familiar in terms of look and feel to most AI developers today. Um, and a module is a holder of objects, just like in Python, and these objects can be imported across modules, can be organized into parent and submodules, just just as you would in the Python world. And workflows is basically a special function, right, that that are composed of other component functions or even sub workflows. So workflows is a special object type in Dana that allows you to compose these functions together to describe complex tasks to perform. And the workflows declared in such form also allow for very optimal execution by the runtime. So by the way, Dave and Tim, how are we doing in terms of time? I know that it's top of the hour, and several folks probably need to go. Could you help me see? Or would you like to make other announcements after this, or can we go on a bit with the Q&A?
Yeah, we can go on with Q&A. We've done that in the past. If there's interest, if there's more questions, anyone here still around, feel free to ask more questions. If you're happy to stick around for a little bit longer, we can go over. That's perfectly fine. Thank you.
Yes. Let me pick a few more very technical questions about memory. There is a question of whether Dana's memory is persistent beyond a certain session. Yes, you already saw that memory is persistent beyond a single session, and then we will make this configurable as well. Basically, memories are tied to the interactions with a particular user, right? For example, if I log into my computer as another user, right? The same computer but another user, then the same agent Dave would treat that other user differently than my current user. Right? So a lot of these can be configured to what extent, right? To what does what is the scope of memory, and what are the entities that are recorded in terms of the interactions, and how long the memory will be recorded, right? So memory management is a key aspect. There were many sensible defaults, but they're ultimately configurable for complex systems. And yes, they are written down somewhere on disk, right? In some user cache. Right. So how can we have multiple? Andres raised an interesting question. How can we have different versions of an agent? That is very, very interesting. So let me show you a way to create agents that are alike in terms of their capabilities, but are independent in terms of their identities. So there is a concept called the agent blueprint. Okay, so as you already could tell earlier, the keyword agent actually declares a singleton instance. So when I say agent Dave is already an instance. There is only one single version of Dave. But if I want to make a class of agents that are similar and share some properties, I can use this new keyword called agent blueprint. Okay. And I like to say special ops, right, agent. Okay, so oops. Okay, so let's for the moment let's just say they are all financial analysis agents. Um, okay, because that is the expertise module that I have prepared for this session. Now, once this blueprint called special ops agent, I can make multiple instances of it. Okay, and say, okay, I can have Ethan Hunt being one special ops agent. Okay, I can have yet another special ops agent. Okay, I can say, hey, Bond, James Bond. Okay, there is some. I think I made a wrong indentation in expertise, so it didn't register. I should have spaced by 4 characters. I spaced by 5. There's some misprocessing here, but let me check again to okay, so I need to assign again. I mistype a space, but you can see that Ethan Hunt and James Bond are both instances of special ops agents, and then now they can branch out and perform different tasks, but they do possess similar capabilities. And where this is useful is when we have a template of industry-specific agents. For example, semiconductor equipment troubleshooting agents, right? Semiconductor equipment is very technically complex, and they are configured differently from manufacturer, from site to site. And so when we have let's say a troubleshooting agent blueprint, when we create agents that are specific to a certain manufacturing site, we will have to instantiate it with certain access to local resources, certain special documents that are particular to the place, certain special site specific knowledge. So those are instance specific attributes that can be given to specific instances of the same class. So this is where the agent blueprint concept is helpful in retaining some generality across a class of agents while allowing you to customize per deployment. So hope that answers the question from Andres.
Oh, that sounds pretty good. And by the way, this is the real Dave speaking. Earlier, I thought you were asking a question of the agent Dave. So sorry for being late there.
Yeah.
Looks like you answered his question. He said, sounds good. And looks like we've kind of covered the questions. So actually, I'm not sure. Did you cover the question in the Q&A window?
I
A while ago.
Q&A window. I have been monitoring the chat.
Yeah, there's one that says, Wesley says, from the UI perspective, how are you organizing the multi-threaded nature of this example 007 in on thread and math in another thread?
Oh, in terms of managing the computation of the task that agent 007 performed?
I think so, yeah.
That is basically automatic. Well, underneath the data runtime, obviously there are multiple threads being created to execute the computation for, let's say, if we ask 007 a question on capital intensity, we know that there are 4 parallel, the 4 independent tasks that can be done. So there would be at least 4 threads created to perform those tasks, and then the results from which are combined later on. So that level of management of the computing resources is basically handled automatically by the runtime. We don't see it. We don't need to manage it.
Got it. Okay. All right, good. Another question here. How much RAM and GPU is needed for a reasonable agentic server?
Right. So that is a great question because it goes directly. It's an initiative that we are driving, and it's part of a coming major release, which is what we call local first. Basically, Dana will be maybe the first agentic AI ecosystem that really treats the local LLM as the default. Right. Most of systems today would be tied to some cloud providers, some hyperscalers. Google would like to you to call the Google LLM. OpenAI would like to use the OpenAI resource. We would like to basically make agentic development possible on usual laptops. Obviously, maybe with the minimum memory of 16 or 24 gigabytes. And we are also optimizing data for private cloud or on-prem deployments because a lot of the members of AI Alliance are manufacturing companies, and they have a lot of what we call edge computing, or there's a lot of systems that are run independent of the internet. Right. So there is a great need to run agentic intelligence in a no internet or in a private network setting. So the resources available in such an environment vary. It can be a single beefy laptop in a special room. It can be a full private data center. Right, so let me go back to my slides, and before we break from this session, I would like to invite you to fill out, join us in the private beta program by scanning this QR code, where you would basically see a Google form, and if we could have your names and GitHub IDs, we would send you invitations into the private beta program on GitHub, and through which you can see our ongoing development. A lot of exciting features and releases are coming. But thank you a lot for the great interactions in today's office hour. And the slides, Dave and Tim, could I have your help to distribute to the attendees after this session?
Yeah, absolutely. And we can send the email out to everyone, get the link to the slides. Yeah.
Yes. Thank you.
Great. Hey, thank you very much, Vin. And thank you, everyone, for joining. And this is a very deep dive into Dana and programming with AI. So I appreciate your presentation, Vin. And thank you, everyone. We look forward to seeing you again next week. All righty. Take care, everyone.
Thank you.